Welcome to part 1 of the Competency 8 quiz. In this video, we will answer questions relating to exponential and logarithmic functions. Okay, number 1, which one of the following is equivalent to x? Okay, well, if we follow the rules of exponentials, let's look at the first one. If we take this 10 and we bring this 10 down in front of the log, and then we have log of 10 to the x. If we set that equal to x and we think about our laws of logarithms, it just isn't going to be valid. We'd have this 10 here in front to deal with, and that means that we would have 10 over x, and then we try to solve for the x. It's just not going to come out. No matter what we do, we wouldn't be able to simplify that to just x. So if you think about it and look at it, you can see that that simply won't work. So there's no way that that's equivalent, okay? All right, now, let's look at B. Well, we have the same thing going on here for B, okay? So if we set that equal to x, one side would not equal x if we tried to follow through. So what are we looking at? We would have x in front of the log of x to the 10. Well, you just can't see. If you look at it, there's no way that can be equal to just x, because log of 10 log base x 10 is simply not going to equal 1. It would have to equal 1. Okay, and that's just not valid. So that cannot equal x, okay? All right. So then we see that that isn't going to work. Okay, but let's look at C. All right. So how's this going to work out? Well, that is 10 with the exponent of log of 10 to the x. So if we applied log to the entire expression, let's see what would happen to that expression, okay? So let's do that, okay? So let's say, now if we apply log to this expression, this, according to the rules, log, the exponent comes down to the front, log 10 to the x times log, now understood 10 to the 10. Okay, that's really what's happening. Now, if you pop this into your calculator, you can just say log of 10 because our calculator is understood 10. And then we push enter. That's 1. So what do we honestly have? We have the log of 10 to the x. Okay, because the second expression is equal to 1. So that's what we have. Now, could we actually say that that would be equivalent to x? Okay, so let's think this out. Okay, hang on 1 second. Let's see here. If we put that equal to x, would that actually be a valid equivalency? Let's see here. If we think about our values of exponents, then that would be 10 to the x equals x, because this would be our argument. X would be our argument, and 10 would be the exponent. So I would say yes, the equivalency would be equal. That would, and if you went backwards and reapplied, that's what we would have. Okay, so if we actually did that and we applied the log to what we have, from what we have here, we put this in exponential form. And if we go back and apply the log, we will end up right back where we were. It will actually work. Okay, so let's see what we have. Now remember, we're in base 10. Okay, so that is log of 10 with 10 to the x equals log of 10x, okay? But by those rules, this x has to go down in front. Well, log 10 to the 10, we just explained that that equals 1, okay? And we have log 10 to the x. Okay, this is what we have. We've like flipped sides. So if we put in this, hang on, right here, our calculator has an understood 10, and we've already put log of 10 in our calculator, and that was 1. So in reality, we know that we're correct, and this equals the log of x, which is what we have. So either way we put it, we try to manipulate it. C is going to be the appropriate answer. Now let's look at D. That they're putting log base x. And if you manipulate, I'll let you do that for yourself though. I'm not going to waste any more of your time. But when you manipulate through the base x, you will see that it cannot and will not be equivalent to the variable x. Okay, C is just the only one that really works given our rules of logarithms. Okay, now let's look at number 2. Okay, if a equals log h r of base h r, and then C equals log base h t, then which one of the following is equivalent to a plus 3c? Okay. All right. Well, we really have to look at that. If we're adding two logarithms, we're multiplying. And that being said, we know that this A might work, B might work, but it is highly, highly unlikely that C or D is going to work. How that could be manipulated, because we just don't simply put the arguments together. Okay, that isn't how we manipulate these things. Okay, all right. So let's do this. All right, if we have them added. Okay, so let's put this together. All right, A equals log. Oh, let me arrow down. I turned my pen off. Okay, we have log of, did it again, log h r plus 3 log h t. All right, so what are we going to do here? Let's rewrite this of log h r plus log of h, if I can write h, t to the third. Well, that's one thing we know that has to happen. Our exponent has to be with the t. Okay. Now, and what we know that we can do is we can multiply. Okay. So let's look at which option would be valid. Okay, I'm looking at what I did before. I think that that's not going to be correct. Okay, so if we can multiply in our rules, if you go back and look at your actual rules of your logarithms, when two logs are added with the same base, that means that the arguments are multiplied together. So what do we really have in the end? This is going to equal the log of h with the two arguments r and t to the third multiplied together. So which one of these items is equivalent? Well, no, it's not A, it's not B, and D has the exponent on the outside, and also B did, and that's a dead giveaway that it will not be equivalent at all. So the only option we really have is C. Okay, let's move to number 3. Assume base 10 is used, which is really convenient because then we know it'll work in our calculator. What is the value of x in the equation? Log 4 minus log x plus log x plus 2 equals log of 7. Okay, now there are some things that we can do to manage our equivalency. The first thing is we need our log with the constants on the same side. So we know right away that we need to subtract log of 4 from both sides, which will give us, and I'm going to rewrite this situation too. Let's rearrange our variables, our logs with variables, and say this: log of x plus the 2 minus log of x equals log 7 minus log 4. Now we know that when two logarithms are subtracted, that we are actually dividing our arguments, okay? And every term has a log. So it is appropriate to drop the log at this time. So what are we looking at? We are looking at x plus 2 over the x equals 7 over 4. Okay. And you could follow through, and we will follow through. But I still want to show you something else in the calculator, okay? I will follow through and get this in two different ways, and you can decide which one is best for you. Okay, first I see 7x equals 4 times x plus the 2, which gives us 7x equals 4x plus 8. Now I subtract both sides by 4 to the x, 4x, excuse me, minus 4x minus 4x. And in the end, I have, see, we can go up just a tiny bit there. I have 3x over here, 8 over here. Oh. Well, I'm touching things. Let's see here. All right, let's go back down to where we were. And 8. That just may not work at all. Okay. Okay. And 8. And as you can see, that gives us x in 8 over 3, which equals 8 over 3. Okay, and D is the correct option. So I worked it out by all longhand. The truth is, you probably didn't have to do all that. I mean, it didn't take us long. It's not a big deal. If my computer would have stayed stable, it would have been fine. But let's do this. Let's say math, arrow up to C numeric solver and push enter, which we've used this in other videos and seen that it actually is very helpful. So let's put a parentheses here. All right. So, or actually, we don't even have to use parentheses. We could just use a fraction. It is up to you. I've done it either way. Let's go over to number 1. You saw what I did. I did alpha, window, and then I arrowed over. If you look at the buttons I pushed, and then I have number 1, so you just push enter, and now you can just put in what you see. So x plus the 2, arrow down, put in your x. Now we have to go down to E2. That means expression 2. So we put in the expression first that was in on the left side. Now let's do the right side. And that is just 7 divided by 4. Now let's push. Actually, I was pushing graph, but I intuitively, I know that I can also push enter, as you can see. Let's push enter. Oh, let's go back up. It shouldn't be 10. Let me see here. Let's go back. I went back to it. Let's push graph and graph again. Okay, there it is. See, sometimes it works if you push enter, and that was really a bad idea. It, you never know until you play around. So we have 2.6666, 2.6 repeating. Well, do you think that that is equivalent to 8 over 3? Actually, it is, but we can go figure that out by second mode, backing out and just saying 8 divided by 3, and that's what we get. So we know that option D is correct. Either way we do it, we have a way of measuring our results to ensure that we are correct. Okay. All right, let's go to number 4. Okay, number 4. What is the value of x in the expression log to the third base 3, I'm sorry, log to the base 3x plus log to the base 3, 2x plus 3 equals 2. Okay, now there's some things that you can do here. Now, as is, of course, we can't solve it, okay, the way we have it. However, if we look at what our base is 3. And if you remember the rules of exponents and the base of log, how do we get that? We know that if we pull these, we have log here on both sides and they're added. We know the arguments can be multiplied. So we pull those arguments, okay, which gives us a distribution, okay, distribution situation. Okay. And then what do we do with the 2? You cannot just leave the 2 as is. You have to consider the 2, see, because it's the answer. When we apply the logarithm, think about how we do this. That actually is the exponent of the base. So what do we have? 3 to the second power. Now we can solve. So that gives us 2x squared plus 3x equals, I'm just going to go ahead and say 3 squared, and I will show you why. We can put this into our solver. Of course, we could do this by hand and be fine, okay? However, I'll show you by hand, and we're going to come out with 2 answers because this is an uh, it's a quadratic, okay? We have degree 2. Okay, so 2x squared plus 3x equals 3 times 3 is 9. Oh, no, we don't want to do that. Don't want to do that. We want to do this. Minus 9 equals 0. Now, if we try to factor, which I believe we can, we have 2x and we have x, okay? Now, 9, we only have 3 times 3. So let's put the 3 here and put the 3 here. One of them must be negative. I would say that this will be negative and this will be positive. And so we end up with x equals 3 halves and x equals the negative 3. Well, obviously, negative 3 is not in our options, so we need to go with uh, 3 over 2, which would be B. Okay, so now let's use the other way. Okay, I sat and did it all by hand. Did I have to? Well, let's see. Math, arrow up. We're on option C, so push enter. So let's put 2x squared plus 3x in for one side and arrow down and say 3 squared. Okay, and get rid of that 4 that was in there. All right, now we've learned our lesson about pushing enter. We need to use the OK, which is the graph. And remember, we have to push it twice. Okay, and 1.5 is 3 over 2. So we do have a valid answer. Notice that it gave us the non-negative answer. Okay. And if we put that -3 back into the equation, we might not get a good result in the first place. So the 3 over 2 is safe and it is an option. Okay. Well, let's look at number 5 then. Okay. So for number 5, what is the value of x in the equation 9x to the 4 as our exponent equals 12.5? Okay. Well, we can put this, use our natural log. I'm partial to natural log. You could use log. So what are we going to do? If we apply natural log to both sides, this means that the x plus 4 comes to the front, and then we have the natural log of the 9. And that will be the natural log of, on the right side, it will equal the natural log of 12.5. Now what do? Divide both sides by the natural log of 9. And this cancels out the natural log over 9, natural log over 9. And then that gives us, on the left-hand side, we get x plus 4. And I know that this is brave, and I wouldn't show it to uh, high school students, but for a college student or someone who's done with college, this should be fine. You can now subtract 4 right there where you are and see that that cancels. Now we can rewrite, or we can just say that equals to x, and this is what we're putting in our calculator. Okay? All right, so we can do that. All right. So let's do second mode. Now, that would be, I'm going to do this in two parts because I'm seeing some order of operations nightmares. Or I could put, let me get another color. I could put all of this here. Let's just erase this business, right? I could put everything with my ln x. I mean, not ln x, my ln constants, that rational natural log, and put that in and then just subtract 4. So instead of me saying it, let me just do it. Okay. Or I could also do this. Watch. Parentheses, alpha window, and I can go over, grab number 1. Now I have something that's going to deal with my order of operations. Always have order of operations in mind. I can tell you how many times order of operations in the calculator, I did it incorrectly, but yet what I wrote by hand was completely valid. There was nothing wrong with it. It's just my lack of knowledge with a calculator. I had to learn a lot. You don't know everything right away. No one does. Okay, so I'm going to put that in parentheses. Now I'm going to subtract my 4. And that looks pretty good. It looks exactly the way we've written it out. And let's push enter and see what happens. And yes, we have a perfectly valid answer. With some rounding, option C is what we need. Okay. All right. Now, and you can also use other methods and play with some things in the calculator. This isn't the only way to enter this. Okay, that being said, let's use our math and our C. Let's go use our numeric solver. And I'm going to push enter. I have already entered the both of the sides that we had prior. If you remember, let me rewrite it. We had started out before I applied all the steps. We had x plus 4 ln 9 equals ln 12.5. Enter that into, each side just like we do for any equation. Enter it on both sides, and I have it entered correctly. Now let's push our graph twice. Remember, you got to push it twice to get rid of, it's already there. Sometimes, remember, if you have a prior answer, you have to push it twice. So yes, we do actually arrive at a valid answer and we're correct. So like I said, there's more than one way to deal with this in your calculator. All right, this is the last question for this first video of 3 videos for your Competency 8 quizzes. And once again, thank you for watching, liking us, sharing us, and subscribing. You guys are the best. Happy testing.